Types of chemical reactions. As chemists and chemistry students, we deal with chemical reactions all the time. Now, you would think that there is no way to quantify a chemical reaction because they're all a little bit different. But basically they boil down into several classes, and we're going to go over them today. There are 5 basic types of chemical reactions, and all chemical reactions in the world can generally be classified into one of these types. They are single replacement, double replacement, synthesis, otherwise known as combination, decomposition, and combustion. So those are the 5 basic types of chemical reactions that hundreds of thousands of chemical reactions can actually be classified into. So the most simple chemical reaction type is the single replacement. And basically what's happening here is one atom, which is free, is going to replace another atom in a compound. And that atom that it's replacing is going to be now become free. So let's look at it here. So we have a metal, free metal here, and then we have an ionic compound here. Metal, non-metal, so that's an ionic compound. And we're going to replace this metal with this metal. So when we do that, we get a new ionic compound with a metal, non-metal, and then the metal that was once bonded in the ionic compound is now free. Now it just doesn't have to be the metal being replaced. You could have the anion being replaced, or the non-metal, right? So in this case we have an ionic compound with a metal and non-metal, and then we're going to replace it with this non-metal to form a new ionic compound with the original metal, the new non-metal, and the original non-metal is now free. So the analogy in real life would be something like this. Suppose you went to a dance and you went by yourself and you wanted to dance with a person, but that person is already dancing with somebody else. So you would walk over and introduce yourself to the couple, say you wanted to dance, the couple would break up, and then you would dance with your new partner. While the person that was dancing with your person that you wanted to dance with now becomes single and no longer dancing with that person. So here are some examples of a single replacement reaction in chemistry terms, right? And we can look at them here. So here's my ionic compound here, right? And this is my free metal. And then what happens is this metal here is going to replace the silver. So when we do that, we get this compound here because, again, this is putting here and you're combining it with this one here. And now the free metal over here, the silver, is free again. Now we could do the same thing with a non-metal replacement. So let's look at our compound here. This is my free non-metal. Here's my ionic compound with the bonded non-metal. And what we're going to do is we're going to replace this into here. So when we do that, this becomes this, and then this, the chlorine, becomes a free chlorine over here. Just because it remember, just because it has a 3 here doesn't mean it's not free. It's just not bonded to anything else, right? And the thing that stays the same is the selenium. The selenium stays the same in both cases. So the double replacement reaction is an extension of the single replacement reaction in that there are 2 switches going on. So we have compound AX here and compound BY. So what's going to happen is the A is going to combine with the Y and the B is going to combine with the X. So both partners are switching, right? Now let's go back to our dance analogy. Suppose you went to a dance with a partner, with a date, and then but you're not really feeling good about the date. And then you find a person that you really want to go dance with, but they're also dancing with another person, right? And maybe they're not too keen about that date. So you get together and you say, okay, let's just switch partners, right? So now you're dancing with the person that you want to dance with, and the other person that you came with is dancing with the other person that the other person was dancing with. So you basically have switched partners, right? And that's all that's really happening here. You're switching partners, or you're switching atoms in two different compounds. So let's look at some examples real quick here. So you can see here that we have two compounds, right? And all you're doing is you're switching the things. So my lead here is going to combine here, right? And my nitrate here is going to combine with the potassium. And then all you're going to do is now the potassium is going to combine here. And your last thing that you're going to be doing is your iodide is now going to be here. So that's all you're doing. You're just switching everything around. And you could do the same thing here. The sodium goes here, right? And the OH goes here. The bromine goes here. And then finally, the calcium goes here, right? And you can see how this would work on the last one real quick. So rubidium goes to here. The nitrate that was bonded to the rubidium is now bonds to the beryllium. The beryllium was once bonded to the fluorine, bonds to the nitrate. And your last one is that your fluorine now becomes bonded to the rubidium. Synthesis or combination, another fairly straightforward one. It's when two or more materials combine to form a single product, and that's the key word here, right? A single product. So you're going to recognize this type of reaction by only having one product, right? You can have as many as you want reactants, but if you only have one product, then it's a synthesis or combination reaction. So let's just quickly look here. You can see that the phosphorus and the oxygen get together to form diphosphorus trioxide, and then you've got the pentane combining with the iron to get the ligand here. So an example, I'll get back to the dance thing again. Suppose you came to date single and you saw another person that you wanted to dance with, and they were also single. You got together on the dance floor and you formed a dancing couple. Decomposition is basically the reverse of synthesis. Combination is when you take a single compound, that's the reactant, and you're going to break it down into two or more products, right? So you recognize this by having only one reactant, right? So then say that, let's go back to our dance analogy again. Let's say you go to the dance with your sweetheart, and then all of a sudden you get into a big fight, and then you decide that you're going to split up at the dance, and so you came as a couple, but now you're going home as two singles, right? And you can see here from our examples, nitrogen dioxide forms oxygen gas and nitrogen gas, and calcium carbonate decomposes into calcium oxide and CO2 gas. Notice that you only have one reactant, right? Even though there's a two here, there's only one chemical here. The combustion type of reaction is a very specific reaction, and generally it's very confusing to many students. I don't know why, but basically combustion is when a compound, generally a hydrocarbon or something that's made with only carbon and hydrogen, reacts with oxygen to produce CO2 and water. You recognize it by having two things. You have to have oxygen as one of the reactants, and you must have CO2 and water as the only products, right? If you have something else as one of the products, then you either have an incomplete combustion reaction or another type of reaction, right? So here's some examples, right? We have hexane, C6H12, reacting with oxygen. There's my oxygen as a reactant, forming CO2 and water. Here's another one. Now this isn't a pure hydrocarbon, but it has hydrogen, carbon, and oxygen. Again, reacting with oxygen necessary to form CO2 and water. Right? There's really no dance analogy for this. Right? But you have to recognize it by two things. CO2 and water are the products. Oxygen must be one of the reactants. Okay, so I went through the 5 basic types of chemical reactions. Now you're going to practice it. So you can just basically use your notes to look at these. Now look at each reaction here, and tell me what type it is. So you can either write single replacement, double replacement, whatever, down the lines here. So again, at this point in the video, if you've followed any of my other videos, this is where we stop the video. You write down the information on the slide here. You work the problems. When you're ready to start the video again and get the answers, you hit play. So stop the video now. Okay, so there are the answers, right? You should be able to figure out how I did these, right? In the first one, it's a double replacement because, again, you're looking at this and the sodium and the calcium are switching partners. Here you have NH3 and H2SO4. You're forming this new compound here. There's only one product, therefore that's a synthesis. CO2 and water, that should be a giveaway for a combustion, and O2 is one of the reactants. Here you have again a single replacement. Remember, lead is getting replaced by the hydrogen. And then lithium nitride with ammonium nitrate is a double replacement reaction, and the last one is a double replacement reaction. So if you didn't get these, you should go back and quickly review it, look at your notes, and then or come find me in class and I can quickly go over this and review with you.